Hey guys, welcome to ANS Solver. Today we'll be doing, basically one formula. It's an MF19 formula. It's really important. It has been asked in past papers. Okay, and students have actually, gone wrong with it. It will even be covered in further integration, but I'm mentioning it here also. Okay, so basically, it's there in your MF19 booklet, page 4 also. But you need to remember it because you need to know when to implement it. So basically, if I have the integration of something like 1 over x square plus a square dx, how do I, integrate something like this? The integration is basically 1 over a tan inverse of x over a. Okay, sometimes you get a coefficient of x here. Okay, you always have a coefficient of x here. So you multiply it by the 1 over the coefficient of x, correct? And then you add a c. So this is basically the formula which you need to remember. Okay, it's there in the MF19, but still it's better if you remember it. So now let's do some examples. Let's say if I have the integration of 1 over x square plus 3 the whole square dx, correct? So first identify your a. Your a in this case is 3, correct? And your x in this case is actually just x, correct? So you can just write this as 1 over 3 with the tan inverse, okay, of x, which is just x, over a, which is 3, multiplied by, I can do 1 over the coefficient of x. In this case, the coefficient of x is just 1. So I write 1 plus c. Now I can write my final answer just as 1 over 3 tan inverse of x over 3. Correct? Plus c. Understood? Okay? Really simple substitution. Now, what if I ask you something like the integration of 1 over, okay, 4x square plus 9 dx. The first thing which you need to do is convert this into a proper form. I can write this as the integration of 1 over, okay, now you need to pay attention. I need to, get 4x square in a whole square format. So I know 4x square can be written as 2x the whole square, correct? Because 2 square is 4 and x square is x square. So instead of 4x square, I can write this as 2x the whole square plus, I know 9 in a square format can be written as 3 square. So I write 3 square dx here. Correct? So this is in the proper format. So first I write my x. My x in this case is actually 2x. Correct? Because it's here. And the a in this case is 3. Correct? This is what I basically have. So now what I can do is I can write this as the integration, or sorry, not the integration, as 1 over the a value, which is 3, with the tan inverse of the x value, which is 2x, over the a value, which is 3, multiplied to 1 divided by, okay, here I have the coefficient of x. In this case, the coefficient of x is 2. So I simply write 2, correct, plus c. So now I can do 3 into 2, which is 6. So I can just write this as 1 over 6 tan inverse of 2x over 3 plus c. So here you need to understand the coefficient of x which you have here will be multiplied to it. Will be 1 over the coefficient of x. Correct? This is what you need to know. Now let's do one more example. a little more complicated one this time. Let's say if I have 5 divided by, okay, 16x square plus 3, okay, or let's say plus 5, okay, dx. Okay, so the first step is basically take your 5 outside and write this as the integration of 5 over, sorry, not 5, integration of 1 over 16x square plus 5 dx. So first we need to write this, the denominator in a whole square format. So I know first that I can write 16x square as 4x the whole square. Correct? So I can write this as 5 multiplied by the integration of 1 divided by 16x square can be written as 4x the whole square. Correct? Plus, now how do I write 5 in a whole square format? I can write 5 basically as root 5 the whole square. So I can write this as root 5 the whole square. Correct? So this is how you need to think. Correct? So first I identify my a. In this case my a is root 5 here. And the x which I have is 4x. So I simply do 5, okay, which is basically here, multiplied by, first I do 1 over a, which is basically 1 over root 5, tan inverse of x, which is 4x, by a, which is again root 5, correct, multiplied by 1 over the coefficient of x here, which is 4, agreed, plus c. So now what I can do is, first I have root 5 here and 5 here. So I can write this root 5 in the denominator, sorry, in the numerator, divided by, I have the 4 here, so I can write 4 with the tan inverse of 4x over root 5 plus c, which is the final answer. So this formula was very important to mention. We'll again cover this in further integration, don't worry. Okay, but remember this formula because they have asked this in many past paper questions. Okay, it's not that frequently asked, but it's asked. Okay, and it's asked for a lot of marks. And first you need to identify the form which we discussed here, and then implement the formula correctly. Don't forget the 1 over the coefficient of x. This is really important. Okay, there are some other formulas also which I'll mention. They are very uniquely asked, not asked very very frequently. So that's basically 1 over x square minus a square. Okay, 1 over x square minus a square integration, okay, can be written as 1 over 2a ln x minus a divided by x plus a. Okay, this is just mentioned in the formula booklet also. It's not asked very frequently, so don't worry. So this can be written as 1 over a square minus x square dx, which is basically equal to 1 over 2a with ln x plus a divided by, sorry, yeah, you can write it as x plus a or a plus x. A plus x will be easier to remember. Divided by a minus x. Okay, so basically these two formulas here below the line are very rarely asked. Okay, the most important is actually the first formula. Okay, which is basically the 1 over x square plus a square form. That is very important to understand. Okay, so basically these are the identities, okay, which we've covered. Now in the next video, we'll be doing the past paper examples, okay, of these, so that, because now we've learned all the concepts Okay, we'll do the past paper examples, and after the past paper examples, we'll have to do the numerical integration, which is basically the area of trapezium. Okay, so that will basically be the last video. So before that, we'll do the past paper examples so that we are sure how to implement these concepts. Correct? So yeah, see you all in the next video. Thank you very much for watching.